What if I told you? Your brain is not just a biological machine, but a quantum receiver connected to the entire universe. What if your thoughts are not only electrical signals, but tiny quantum events happening at the deepest level of reality? Scientists have discovered that at the smallest scale of existence, particles can exist in two places at once, communicate instantly across vast distances, and behave in ways that defy logic. Now here's the shocking question. What if your consciousness works the same way? What if your mind is not confined to your skull, but is connected to the fabric of the cosmos itself? Today we're diving deep into quantum consciousness theory, the controversial idea that your brain might be linked to the universe at the quantum level. This isn't science fiction. This isn't spirituality. This is where neuroscience meets quantum physics, and reality begins to bend. Before we jump into quantum physics, we need to understand one thing first. What exactly is consciousness? Consciousness is your awareness, the fact that you experience reality. You don't just process information like a computer. You feel it. You see colors, you feel pain, you experience love, fear, imagination, dreams. But here's the strange part. Science can explain how neurons fire. Science can measure electrical signals in the brain, but science still cannot explain why those signals create experience. This is called the hard problem of consciousness, a term introduced by philosopher David Chalmers. The hard problem asks, why does physical brain activity produce subjective experience at all? For example, when light hits your eyes, it turns into electrical signals. Those signals travel to your brain, neurons fire. But why does that create the experience of the color red? Why does brain chemistry create the feeling of sadness? There is no equation in neuroscience that explains how matter becomes awareness. And this is where the mystery begins. The classical brain model. Modern neuroscience says the brain works like a biological computer. It contains about 86 billion neurons. Each neuron connects to thousands of others. They communicate through electrical and chemical signals. According to the classical model, consciousness emerges from complex neural activity. In simple words, more complexity, awareness. But here's the problem. Even if we map every neuron, every synapse, every signal, we still only describe mechanisms. We don't explain experience. That's like describing every wire in a computer, but never explaining what it feels like to be the computer. And that's the gap. Now enters quantum physics. To understand quantum consciousness, we must understand something about quantum theory. In the early 20th century, scientists discovered that reality at the smallest level behaves very strangely. Atoms are not solid balls. They are mostly empty space. Inside atoms are subatomic particles, electrons, protons, quarks. And these particles don't behave like normal objects. They behave like probabilities. One of the most famous experiments is the double-slit experiment. When particles like electrons are fired at a screen, if you don't observe them, they behave like waves. If you observe them, they behave like particles. The act of measurement changes reality. Let that sink in. Observation affects physical behavior. Some physicists began asking, does consciousness play a role in collapsing quantum possibilities into reality? Is the observer necessary? Superposition and entanglement. Quantum physics introduces strange concepts. Superposition. A particle can exist in multiple states at once until observed. Quantum entanglement. Two particles can become connected in such a way that changing one instantly affects the other, even if they are light years apart. Einstein called entanglement spooky action at a distance. Now here's the big question. If the universe at its core is quantum, and your brain is made of atom matter, could consciousness itself be quantum? Could your mind operate beyond classical physics? The birth of quantum consciousness theory. Some scientists propose that classical physics alone cannot explain awareness. One of the most well-known theories was proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their model is called Orchestrated Objective Reduction, Orch-OR. They suggest that consciousness arises from quantum processes happening inside tiny structures in brain cells, called microtubules. Microtubules are part of the cell's skeleton, but Penrose and Hameroff argue they may support quantum states. According to them, consciousness is not just computation. It is a fundamental feature of the universe, almost like gravity, almost like space-time, This idea is controversial. Many scientists disagree, but it opens a powerful possibility. Maybe consciousness is not produced by the brain. Maybe the brain is a receiver or filter of a deeper quantum field. Throws to a new perspective. If this is true, then your mind may not be limited to your skull. Awareness might be woven into the fabric of reality. Instead of consciousness emerging from matter, matter might emerge from consciousness. This flips everything upside down. And this is just the beginning. If your brain operates at the quantum level, does consciousness play a role in shaping reality? Now let's focus deeply on one thing: the observer effect. The foundation of this idea comes from the double-slit experiment. When tiny particles like electrons are fired toward two slits, something shocking happens. If we don't observe them, they behave like waves, spreading out and creating an interference pattern. This means the particle exists in superposition, multiple possibilities at the same time. But the moment we place a detector to observe which slit it goes through, the wave behavior disappears. The particle behaves like a solid object. Reality changes when measured. This is explained in the Copenhagen interpretation, developed by Niels Bohr. It states that before measurement, a quantum system exists only as probabilities. Measurement forces it to choose a definite state. But here's the deep mystery. What exactly causes that collapse? Is it just interaction with another particle? Or does conscious observation complete the process? Mathematician and physicist John von Neumann argued that if you trace every physical interaction step by step, you eventually reach the mind of the observer, meaning the final collapse might occur in consciousness itself. If that's true, then consciousness isn't just watching reality, it's participating in it. At the quantum level, the universe may not be fully defined until it is observed. And since your brain is made of quantum particles, the possibility emerges that awareness is not separate from the fabric of reality. It may be part of the mechanism that shapes it. Panpsychism is consciousness everywhere. If consciousness arises from quantum processes, some philosophers and scientists propose panpsychism. Panpsychism suggests that consciousness is a fundamental property of matter itself, not just in humans or animals, but in all matter down to atoms and particles. In other words, your brain's atoms are conscious. The air around you may have proto-consciousness. The universe itself could be aware at a basic level. This view flips our understanding of reality. Instead of consciousness emerging from matter, matter emerges from consciousness. It's a radical idea. But some of the greatest minds, including Albert Einstein and Erwin Schrödinger, considered versions of this perspective. Could the universe be conscious? Some theorists argue that the universe itself might have a form of awareness. If quantum processes underlie consciousness, and these processes exist everywhere in the cosmos, then consciousness might not be limited to brains. Imagine the universe as one vast quantum field. Stars, planets, and galaxies are ripples. Consciousness emerges wherever quantum collapses occur. You, as a human mind, are a localized node in this universal web. This idea is speculative, but it connects quantum physics, philosophy, and spirituality in a fascinating way. Scientific criticism. Quantum consciousness is highly controversial. Critics point out one decoherence problem. Quantum states in the brain would collapse too quickly to affect neural processing. 2. Lack of experimental evidence. No conclusive experiments show that consciousness depends on quantum processes. 3. Alternative explanations. Classical neuroscience explains many cognitive phenomena without invoking quantum mechanics. Even Penrose and Hameroff admit the theory is speculative, a bold hypothesis rather than proven fact. Why it matters? Despite criticisms, quantum consciousness challenges how we see ourselves. Are we just biochemical machines? Or are we participants in a vast interconnected quantum universe? Even if the theory is only partially true, it opens doors to deeper understanding of awareness, new perspectives on free will, perception, and reality, philosophical questions about life, death, and the cosmos. Practical implications, mind and meditation. If consciousness is linked to quantum processes, it suggests that our awareness might extend beyond the physical brain. This could explain phenomena such as intuition, sudden insights that seem to come from nowhere, meditative experiences, feelings of oneness with the universe. Flow states, moments where the mind operates beyond normal logic. Practices like meditation, deep focus, or mindfulness might allow us to access subtle quantum states in the brain, enhancing awareness and creativity. Even though science cannot fully prove this yet, experiments on brainwaves show that focused mental states correlate with increased neural coherence, hinting at deeper possibilities. Consciousness and reality. Quantum consciousness suggests that our minds are not just observers, but active participants in reality. Every choice, every thought could be influencing outcomes at a fundamental level, not in a magical sense, but in a physical quantum sense. It challenges the traditional view that the universe is entirely external to us. Instead, we may be entangled with the cosmos, shaping and being shaped by it simultaneously. As to future science, if researchers can find evidence for quantum processes in the brain, neuroscience would be transformed. AI and computing could integrate quantum awareness. Medicine might target consciousness at its most fundamental level. Philosophy, physics, and spirituality could converge in new ways. Even if quantum consciousness is partially correct, it reshapes how we define life, awareness, and reality itself. The big takeaway: quantum consciousness theory may be controversial, but it pushes the boundaries. The universe might be more alive than we think. Our minds may not be confined to our skulls. Reality could depend on awareness. You may be more connected to the cosmos than you ever imagined. As we continue exploring the universe and our own minds, one thing becomes clear. Consciousness isn't just a product of matter. It may be woven into the very fabric of existence, and that changes everything.